Okay, let's take a look at ways in which heat can be transferred from one place to another. Heat can be transferred in solids by a process called conduction. Now remember that particles are vibrating in fixed positions in solids, and the heat makes the particles vibrate faster. Particles with greater vibrations get their neighbors vibrating faster too, just because they sort of bump into them. Eventually, all the particles in the solid are vibrating faster, even those that are very far away from the heat source. And this is how conduction works. You know this intuitively. For example, just because you've lived on the planet for a while, you know not to go putting your hand on the end of that iron bar. Even though it's not in the furnace, you know just through life experience that the end will be very, very hot. And that's because the heat from the furnace has been conducted up the length of the bar, and therefore the end is not safe to touch. Heat can be transferred in fluids by a process called convection. Now, fluids are liquids and gases. So liquids and gases, either one of them could be called a fluid. The important thing is that in fluids, that is in liquids and gases, the particles are free to move from one place to another place. And that's important because convection relies on currents to carry the heat from one place to another. That's because the heat will make the particles move faster and get a little bit further apart. So the density of the liquid or the gas very close to the heat source will decrease a little bit. Because those hot particles are less dense, they will rise away from the heat source and cooler particles will take their place. This cycle repeats, setting up a system of currents. This is what drives the sea breeze and why it gets windy in the afternoon. That's because the sun has been warming up the earth, and the earth has been warming up the air above it all day long. That warm air starts to rise because, again, the heat from the land is making the air particles move faster and get further apart. So that means that the air close to the Earth's surface gets less dense than the air above it, and it rises away from the land. It rises away from the surface of the Earth. Then cooler particles come in off the cool ocean to take the place of the hotter particles that have risen. And this is what drives those cool ocean breezes. Another example of convection currents that you will probably be familiar with is in lava lamps. Now, if you've seen lava lamps operating, then that's fine. You'll know what I'm talking about. If you haven't and you would like to, you're welcome to take a moment to click on the link and you can watch, I think that's 30 minutes worth of lava lamps working. There is a third method in which heat can be transferred from one place to another, and that's by radiation. Any object that is hotter than its surroundings will radiate heat. The diagram on the right of the screen, it's actually an image, a picture on the right of your screen, was taken with a thermal camera, a camera that is capable of seeing the heat that radiates off an object. This is a dog, I think, playing in the snow. You can see that the tip of the dog's nose and his ears and the tip of his tail are quite cool. They're blue in color. However, his belly is very hot. It's red to even white. And that's only because the dog is not red hot, of course, but the dog is losing its heat to its surroundings because it's warmer than the air that surrounds it. And so the camera is comparing the temperatures between the coldest parts of the image and the hottest parts of the image. The dog's eyes and his belly are the hottest parts of the entire image, and that's why they appear white. So the heat energy is escaping the hot object in waves. In this case, the hot object is that dog who's just very much hotter than his surroundings. Here's another dog sitting in front of a fire. The dog is sitting here because it feels nice and warm. But that's not because of convection. The convection currents are actually carrying heat up the chimney away from the dog. So if convection was the only heat transfer method at work here, the dog wouldn't be getting any benefit from the fire. Neither would the dog be getting any benefit if he had to rely completely on conduction, because there's no real solid between the dog and the fire itself. Instead, the dog is nice and warm because the heat is radiating away from the fire in all directions, including outward toward the dog. Now, radiant heat of this kind can travel through gases like the air that separates the dog from the fire, but it can also travel through vacuums. That means it can travel through empty space where there are no particles. And this is very, very unlike conduction and convection, which both rely upon the motion of particles in order to transfer the heat. This is how the hot energy from the sun manages to warm the earth. Those are the three methods of heat transfer: conduction, convection, and radiation.